Today we're going to be looking at two specific types of functions. We're in Chapter 3, Section 6. Okay, we're going to be looking at direct and inverse variation. Now, I've got a lot of stuff written here, so remember you can pause the video to play catch-up if you have to. We're going to start with direct variation. Now, just in general terms, direct variation is, in general, as the input increases, so does the output. The higher my input, the higher my output, okay? Now this part's important also. If the input is 0, the output is 0. It's a fancy way of saying it goes through the origin. If we were to graph this, it would go through the origin. Well, one particular type of direct variation is speed. So we're going to look at this example, hello. Graph the function to go with you riding your bike at 20 miles per hour. Okay, so this meets all the conditions here. If you go for 0 hours, you go 0 distance. So it's going through the origin. And then for each hour you add, you go a little bit more. 1 hour you've gone 20 miles, 2 hours you've gone 40, 3 hours you've gone 60. So it meets the conditions of direct variation. I've jumped ahead, and again you can pause, where I've created a table and I've started a graph. So let's fill in the table right now. If you go for 1 hour at 20 miles per hour, you're going to go 20 miles. If you go for 2 hours, you're going to go 40. If you go for 3 hours, you're going to go 60, and so on. You see how that's growing. Okay? Now, we can jump ahead a little bit. Let's go ahead and put the 0 or the y-intercept in. If you go 0 hours, you're going to go 0 distance. Fair enough. So let's write a function for this. We've got d of t, distance as a function of time, equals. Now I know ahead of time this is going to be linear, so we're going to treat this as an mt plus b. So t is the variable, m is the slope, b is the intercept. M equals delta y over delta x. Okay, my change in y's is 20, because this is 20. And my change in x's, that's 1, so this is 20 over 1. So I've got distance as a function of time is equal to 20 over 1 times the amount of time you do it, and my b is 0. It's going to go through the origin. Because again, if you go for 0 hours, you go 0 distance. So I'm not even going to put anything. I can simplify it to this. Okay? So that's the function, and now let's graph it to see what that looks like. So 1 hour gets me 20 miles, 2 hours gets me 40 miles, 3 gets me 60, 4, 80, and so on. So you can see that this is a straight line function, and it goes through the origin right there. So this is the graph of d of t equals 20t. A very standard direct variation type problem. Let's make a note here. Direct variation goes through 0. Okay, so it goes to the origin, 0, 0, and that's a must. Now, we talk about the general form. The general form, so in general, or in general form, a direct variation fits y equals kx. Okay? X is the input multiplied by some constant, and y is the output. We call k is the constant of variation. And it makes sense because, for example, here it's 20, the k value is 20. It's the slope, it's the rate of change. It's how the function varies for each hour you go. So slope, rate of change, constant of variation, all mean basically the same thing. So don't let that confuse you. I've got another, we're going to expand on this a little bit, but it does show you this is what a direct variation graph looks like. And this is the general form of the equation of a direct variation. Okay, if you think about this, this is y equals mx plus b, except b is not there because it's always 0. K, the constant of variation, is just another name for slope. So y equals mx. All right. Let's go to the next page. And let's just look. Let's say I gave you these two and asked you, are these direct variations? The easiest way to do that is just take this and put it into slope-intercept form. So subtract 5x from both sides. Okay, we do this. The 5x's cancel. I have 2y equals negative 5x. Divide both sides by 2, and y equals, the 2's cancel, negative 5 over 2 times x. So yes, you can see this fits the form y equals kx, where the constant of variation k equals negative 5 over 2. Okay, so this is a direct variation. Now let's look at one that's not. So we've got 3y plus 4x equals 8. We're going to subtract 4x from both sides. So again, I'm putting this into slope-intercept form. These cancel. I get 3y equals negative 4x plus 8. Divide everything by 3. Those cancel, and y equals negative 4/3 x plus, what is that, 2 2/3? Well, if you look at this as slope-intercept form, y equals mx plus b, the intercept would be 2 2/3, not the origin. So this is not a direct variation. Okay? So that's what you do if you're given an equation, you want to find out, is it direct variation? Just put it in slope-intercept form. If there's a b, it's not. If there isn't a b, it is. Okay. Now, write a direct variation equation that goes through the point 4, negative 3. Now, because it's direct variation, I actually know 2 points here. I know that point is on the graph, and I know the origin 0, 0 is on the graph. Okay, but let's just write y equals kx. So that's the general form of a direct variation. Well, I have an x I can put in, and I have a y I can put in. So I'm going to go negative 3 equals k times 4. Okay? Divide both sides by 4. So this cancels, and I get k equals negative 3/4. So the constant of variation is k equals negative 3/4. So I can write y equals negative 3/4x. That is the equation. That is the direct variation equation that holds that point. Okay? So just one example for that. If you need to, go ahead and re-watch the video to give you an idea. I'm only doing one because this video is going to get a little long. So let's put this aside and let's talk about the other one. Let's talk about inverse variation, okay? Again, I've got a lot of stuff written here, so if you have to, go ahead and pause the video and get caught up. So in general, now this is inverse variation. As the input increases, the output decreases. So the higher your input, the lower your output. Okay? Higher your input, lower your output. And let's take a look at an example. This is example ransom. Now, this example probably doesn't mean a lot to you because nobody uses CD burners anymore. But let's say you were going to make a whole bunch of copies of a CD, right? Well, doesn't it make sense that the more CD burners you have, the less time it's going to take to make all the copies? So, well, here we go. If you have one CD burner it's going to take you 36 hours to make all the copies you need to make. Now, if you add another burner, you'll cut this time in half to 18. If you add another burner, say 3, you're going to cut this down to 12 hours. If you add another burner in, so now you've got 4 CD burners, it's only going to take you 9 hours. And if you add, let's go 1, 2, 3, 4, let's just go 6. If I have 6 CD burners, it will only take me 6 hours. There's a ratio going on here, okay? Notice, I want you to notice something. What is 1 times 36? What is 2 times 18? What is 3 times 12? What's 4 times 9? What's 6 times 6? Do you see the connection to them all? Let's plot this, all right? If I have 1 CD burner, it takes me 36 hours, which is right about there. 2 is 18, so let's say that's 15, 18 is right about there. 3 is 12, maybe right about there. 4 is 9, and 6, which is out here, would be 6 right about there. And you can see it's not linear. It's actually a curved function that looks like that. That is a classic inverse variation function. Not linear, doesn't go through the origin, and the higher your input, the lower. So the more this goes along the x-axis, the lower the y value is. It drops down like that. Now, the general form of an inverse variation is y equals k divided by x. Now, sometimes you also see that as x times y equals k. These are the same thing, it's just we've taken this, multiplied both sides by x, and you get xy equals k. So for this problem, we just have to take one of these ordered pairs. So let's try 2 and 18. X equals 18, y equals, nope, sorry, totally wrong, scratch that. When x equals 2, y equals 18. So we've got x times y equals 2 times 18 equals 36. So my constant of variation, in this case, k, equals 36. So the equation for this guy right up here, you can put it in either one of these forms. You can say y equals 36 divided by x, or you can say xy equals 36. Either one of those are acceptable forms for an inverse function. So in this right here is the general form of an inverse variation function right there. So if you have to pause, write that down. And again, well, here's something else. I could have used any one of these ordered pairs. I could have used 136, 312, 49, 66. When I put those numbers in for x and y, I always would have gotten 36 out. I would have gotten the same equation. Okay? That's also important. Okay, let's look at the example Oklahoma. I don't know why I went from Adele songs to a Broadway musical, but just go with me. So I've got 2 points, 3y and 5, 9. And I'm telling you ahead of time, they are on an inverse function. And I want you to use this information to figure out what that missing y value is. Here's the missing y. I know some of you think that looks like a 4, but that's a y. There are 2 ways to do this, but they both start with 5, 9. So general equation, y equals k over x. You can use the other one. I'm just old, so I use this one. This is the one I learned. So we're going to take the point we know with the x and the y. X is 5, y is 9. We're going to plug those in. So I've got 9 equals k over 5. Multiply both sides by 5, and k equals 45. Okay, so that's the k value. Now I'll use that k value with this point. So y equals k over x. So y is the unknown, so I just have y equals. k is 45. It's the same k because they're both on the same inverse function, divided by 3. So y equals 15. That's one way to figure out what that unknown y was. There's another way though, and that's to use this form, xy equals k. Where is it? Xy equals k. Xy equals k. Well, doesn't k equal xy? So xy equals k equals, so if I treat this point on this side and this point on this side, I can write this. 3y equals 5 times 9. I can just drop the k. I don't need the k in the middle. So now I've got 3y equals 45. Divide both sides by 3, y equals 15. So you can use either one of those to figure out what the y value is. So we've hit a lot of information. We did direct variation, which is in the general form y equals kx. It's a straight line function through the origin. We did some examples. And then we looked at inverse functions. This is a classic inverse function